Welcome back to Old School Math. Today we're going to take a look at graphing systems of equations by hand. The I can statements for this lesson are as follows. I can graph a system of equations and I can also identify the solution to a system of equations from a graph. We'll need to be able to do this in order to do this. So what is a system of equations? A system of equations is just a set of equations that work together. If you graph two lines, you should have three different possibilities. First thing, the lines could intersect at a single point. This would give you one solution to your system of equations. The lines could be parallel, that is, they would never touch. And if you think about it, if the line's intersecting point is the solution, if the lines never touch, you just have no solutions. And then if the lines overlap, if it's the exact same line, then you have infinite solutions, and it's all the points on that line. The lines could intersect, and they can only intersect if the slopes are different. If the lines never touch and you have no solutions, that is because the slopes are the same and your y-intercepts are different. Now, if the lines are identical and you have infinite solutions along that line, that means the lines must have the exact same equation. So, the solution to a system of linear equations will be one of the following: a single point, no solutions, or infinite solutions along the line. If the system intersects at a single point, be sure to find and label this point. It is the solution that we're after. Graphing by hand, just so you know, isn't always the best method to solve systems of equations. It doesn't mean that it doesn't work all the time, because it could. But if you think about graphing by hand, there might be times where the lines don't meet up on a certain grid mark. And then it's really hard to figure out what that fraction is in there. That might be a time where you might want to hop over to a TI-84 calculator or Desmos.com, and I'm going to show you both of those options in a second video. Okay? And you can do this without technology. So, again, if you're working on the ACT and you need to figure out where lines intersect, well, I could make a little sketch by hand and probably be able to guess the right answer there. Let's take a look at a couple examples together. In this first example, we've got the line y equals x. We'll graph it in green. Now, if we notice here, there's no y-intercept. There's no plus or minus some number. And there's no slope written in front of x. Because there's no slope written in front of x, we know that it is just 1x plus 0 would be another way to write that equation. We're going to start at our y-intercept of 0 at the origin. And since our slope is 1, we'll go up 1 and to the right 1 and up 1 and to the right 1. And maybe for good measure, we'll go to the left 1 and down 1 so that we can continue the trend of this line. So there's our first line, and our second line is y equals 2x plus 1. Now, if you need to pause the video and make your own graph as you're going, please feel free to do so. We notice this slope is 2 and the y-intercept is 1, so let's go ahead and put those on our graph. We'll start with our y-intercept at 1, and the slope is 2, which means we'll go up 2 and to the right 1, up 2 and to the right 1. We'll also go down 2 and to the left 1, down 2 and to the left 1. And we see this intersecting point right here. Let me go ahead and finish drawing my line. Okay? And that intersection point we said is our solution. So that is at the point -1 for the x value and -1 for the y value. Let's go ahead and write that for our solution. -1, -1. Our second example looks a little different. We have a slope for the first equation. We have a slope and a y-intercept for our second equation. Let's see where they intersect or if they intersect. Well, if we take a look at our notes, we know that since the slopes are different, they'll intersect. So let's start with our first line here. Y equals -2x. Again, there's no y-intercept, so it starts at the origin. Since the slope is negative, we're going to go down 2 units and to the right 1. So down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And we'll also continue this pattern up into quadrant 2. Okay? We'll draw our line as straight as we can through here. Looks good to me. Then this second line, y equals 4x minus 6. Well, our y-intercept is down here at -6, so that's where we'll start. And our slope is going to be pretty steep. It's 4, so we're going to go up 4 units. 1, 2, 3, 4. And to the right, just 1 unit. And there's our intersecting point. I'm going to draw one more point on this so that I can make sure that my line stays nice and straight. So you can get a, well, that's crooked. So you can get a good visual on what's going on here. That's pretty good. And there's our intersecting point. The intersection is at the point x is 1 and y is negative 2. Let's go ahead and write that down as an ordered pair. 1 comma negative 2. There's our solution. In the third example, we have two different lines, both with a slope of 3. Now if you look back at your notes, you know that if we have a similar slope or the same slope but different y-intercepts, then the lines are going to be parallel. Let's graph this just to check that. Y equals 3x plus 2, so we're going to start at 2 on the y-axis. That's our y-intercept. And our slope is 3. 1, 2, 3, and over 1. 1, 2, 3, and over 1. Down 1, 2, 3, and to the left 1. All right, and we'll draw our line as straight as we can. And then on the second graph, y equals 3x minus 1. We'll start at minus 1. We'll go up 1, 2, 3, and over 1. We'll go up 1, 2, 3, and over 1. We'll go down 1, 2, 3, and over 1. And so when we draw these two lines in here, we see that yes, they are indeed parallel. They will never touch. And we see the spacing between these stays consistent throughout the whole line. So what do we do with our solution here? Do they ever touch? Again, where they touch, that's the solution. On this one here, there are no solutions. Well guys, I hope this has given you a good understanding and a good overview of how to solve systems of equations by graphing. Go ahead and subscribe to this channel, Old School Math, so that you can get notifications on when I'm posting more educational content helping you through your Algebra 2 course. Thanks for watching.